If you're looking to help the world and buy a home at the exact same time, then you have to contact Climate Change Realty. Visit ccrealty.org to find your real estate agent anywhere in the USA and donate thousands of dollars to your favorite environmental nonprofits absolutely for free. Welcome to the podcast. Steven, really great to meet you, man. Thanks so much for taking some time to come on the podcast. Here we are.
Really good to meet you as well, Ethan. Great to be here.
Yeah, great to have you, man. And we always like to get the show started with a bit of background on who you are and how you got to be doing what you're doing at the current moment.
Yeah, so I studied electrical engineering, did a master's, and um, during that time, I was just trying to think of different things that I wanted to do after I graduated. So basically, doing everything except for work on my thesis. And one of the things that I came across was, this question was, what's going to happen with all these electric vehicle batteries once the vehicles are retired? And there wasn't a good answer to that question. Nobody really seemed to have that answer. There's a lot of people talking about recycling now, which is a really good thing that ultimately needs to happen. But in between, there's still a lot of value in those batteries. And so that's kind of, I just kind of got fixated on trying to make that a reality. And that's kind of the genesis for Rejewel and what we're trying to do and where we are today.
And where did your desire to study electrical engineering come from initially, do you think?
So it's a funny story. It's not what you'd expect. Like, I wasn't one of those kids who are like, oh, I've always been drawn to electronics or computers, any of that. I was trying to choose a major, and my dad said, you should do electrical engineering. And I was like, okay. And then I loved it.
Well, lucky you. The first
Yeah,
shot, first try, you got it down. Maybe he knew something you didn't, man.
yeah, definitely.
Yeah, that's funny. Okay. So I wanted to start this conversation off by trying to understand what exactly a battery is and how it works. Cause I think a lot of people don't really realize that there's like these acids and things that we're walking around with in our pockets. And they're kind of, like you said, they're becoming fundamental to the way we live. They already are fundamental to the way we live
Yeah.
our lives, but it sounds like they're going to become even more important. So I was wondering if you could just kind of walk me through the very bare basics of how batteries work.
Well, I'm not an electrochemist, so for any electrochemists out there listening to this, I apologize in advance. But a battery is an electrochemical storage device, and so it stores electrical energy basically, and it stores that in the form of some fun chemistry things that are happening inside that battery. Um, and when you charge a battery, you put electrons in. Um, there's a certain electrochemical process happening, and that allows you to charge up the battery. And then you can use that charge for later on when you discharge that battery. And one of the things that we look at is how those batteries degrade. The more you charge it and discharge it, the different temperatures you put it in, just different ways of how you use it, ends up affecting how that battery performs in the long term. So I used to just think of a battery as a power source. It just kind of did its thing. But then once you get into the science, there's a lot more to it.
Well, so with these batteries, isn't there like acid flowing from one side to like another, and then when you charge it, it like pushes the juice like back into the other side? Is that or is it like electrons are flowing? What's like there has to be something like physically leaving the phone when you're using it, no? Like some sort of release of energy that's happening?
Yeah, so I guess a battery, there's an anode and a cathode, and then there's a separator in between, and then there's some other things. But essentially, one's positive, one's negative charge. And when you charge that battery, there's lithium ions moving from one part of the battery to the other part.
Mm-hmm.
And then when you're discharging that battery, lithium ions move back. And then as a result, you need to, in a way, balance that charge so electrons move through the outside of that battery through a circuit.
Okay. I'm
If
I'm
that
I'm
makes
trying I'm trying to wrap my head around it. Okay. Is there So it sounds like there's these several scientific parts that I don't fully understand. Is there any fundamental limit to like a battery? Is it just how many like lithium ions we can have? Could we make like a giant battery that could power like something big, or is it like decrease in efficiency the larger it gets, kind of thing?
Um, there's definitely fundamental limits, and there are practical limits for how batteries are, put together. We can make a extremely large battery, and it'll probably work. It just won't be very useful to anybody.
Okay.
um, yeah,
Yeah, because I guess one of the benefits of the battery is being able to take energy with you, like on the go. I suppose whether it's in a car or in like a phone kind of thing.
right, right. And so there's all these people doing different things with the batteries, like innovating on the cathode, innovating on the anode, changing the liquid electrolyte to a solid electrolyte, and doing all these different things changes the performance of the batteries. You have things like how much energy can you pack in, how much power you're able to get out of it, how light the battery is, um, how the shape of the battery, how hot it gets, how long it lasts. And so by adjusting these, the internals of the battery, then you get different performance. And that's what a lot of different people are working on to, say, make a Tesla go from a 300-mile range to a 400-mile range,
Right.
even longer. Um, or there's people doing things to be able to charge your car in 5 minutes versus typical fast charging now is maybe an hour or maybe even longer.
Okay.
Yeah,
So how long, if these batteries like eventually become unusable, how long is like the average electric vehicle battery last? And yeah, it's to start there, definitely.
yeah. So they're designed to last over 8 years, 8 to 10 years. That's generally where the warranties are set at, um, and um, and then the the large batteries that people are starting to put on the utility grids, to pair it with solar and wind and other renewables, those are designed to last even longer, 20 to 25 years now.
Okay. And what happens at the end of their life? What happens to like a battery if someone, let's say a car, 10 years old, the battery is shot? What do they usually do with it?
Yeah, that's a really good question. And most people, or I should say, that hasn't really happened too much yet because electric vehicles haven't been around for, I guess they've just now hit their 10, 11-year mark. So most people haven't had that problem, first of all, and so what people believed is, well, this battery may be at 70% capacity. Let's throw out a number there, or 80%,
Okay.
um, and maybe the best thing to do is to take it out of the vehicle and to put it in a different application. Just put it on the grid, have it charge through solar, discharge during the nighttime. Um, But then I think the real answer is nobody really knows yet because we haven't really reached that at critical mass. People are starting to build up recycling capabilities. And then there's also the collection aspect of it. How do you get a battery from somebody's garage into that recycling center or into a repurposing center? Um, so so there's a lot of different ways, a lot of different things that people can do, and I think we're just starting to see, just starting to be able to answer that question.
Yeah. Well, it's definitely something we want to be thinking about. Do you know
Mhm.
what they do with wind turbine blades after they're done being used?
I've seen a few articles. It From the
It's
looks of it, it looked like they were like putting it into the ground.
Yeah, man. Like that's
Is that
crazy.
all
Like
they do?
That yeah, they just bury them. Like we're
Okay.
building these renewable energies and talking about how we're going to heal the planet through wind and solar, and they're taking these giant pieces of plexiglass and burying them in the sand because they don't know what to do with them. So it just be nice to get on top of this with I don't know if the right word is like volatile compounds or whatever that are in batteries. But when you say 70 to 80% is a
Uh,
dead battery, I mean that's not terrible. If it still can do 70% of what it used to, sounds like you hooking it up to the grid or something could be a good utilization of that tech.
right, right. And then us, we should also caveat like there's like I mentioned before, there's all these different performance characteristics, right? So 70% of energy may sound perfectly fine, but if it can accelerate a vehicle from 0 to 60 in like the 5 seconds, or even 30 seconds, then it's not very usable in a vehicle at that point. But it could still be, like you were saying, very useful for just charging and solar and discharging during peak hours and things like that.
Yeah. Or I think powering a solar powered I just direct air capture device comes to mind. It's a direct air capture device that's powered by solar, so it's sucking out carbon at night too. That's just what my mind goes to right
Interesting.
away. I just any energy we can use to pull CO2 out of the atmosphere at least for the next 20 30 years. I'm all on board with. Well, cool man. What do you know about the global battery market? Like how many batteries are being produced and where is this thing headed in the next like 10 years?
There's so many different articles out there that I tend to lose track. I saw um, there's like 20, I think 25, I think 13 gigafactories planned for the US alone by 2025,
That's just
and
Tesla.
something that's I think that's overall.
Okay, gigafactories. Other
Yeah,
companies do that
gigafactories.
as well.
Like, yeah. Tesla has their Nevada plant and their Austin plant now. There's a few other battery companies building their own. And then I think in Europe, there's something like 20 to 30 in the plans. I always lose track because I feel like there's a new announcement of a gigafactory every week or so.
I'm down with that.
Yeah, that's a lot of batteries.
Yeah. Well, you're out
Yeah,
here running a business too. You know, it's tough just to
yeah,
keep on track of everything. I try to not pay attention to the news at all. Real estate is enough. You know what I mean?
for sure, for
Yeah.
sure. And there's a flurry of things happening in the battery industry right now. With all the development, there's some really interesting trends, especially recently. Like the cost to produce a lithium battery pack has gone up for the first time in a decade,
Okay.
and that's due to the price of raw materials like lithium, cobalt, nickel, all these really critical materials for making a lithium-ion battery. Those have shot up in recent months. Global supply shortages, the crisis in Ukraine, all these things have really, um, yeah, just made the cost of producing a lithium battery increase. And so, and then there's also like people talk about nickel shortages, cobalt shortages. And then, so there's a huge shift now from nickel based batteries to LFP batteries, actually.
What is that?
Are you familiar with the differences?
No.
So there's different battery chemistries. So Tesla famously used the nickel, cobalt, aluminum, um, and those were higher, NCA batteries, and those were higher performance. And then there's NMC, which a lot of people use as well, and then there was LFP, which a few years ago it was mainly just Chinese manufacturers using, and a lot of the European and North American um, automakers didn't want to use LFP because of like low energy density. So you couldn't pack as much energy into that battery pack for the same size and the same weight.
But it performs better, but it doesn't store as much energy. Am I understanding that correctly?
It doesn't store as much energy, so it's heavier.
Okay.
Yeah, and then it doesn't perform as well in terms of being able to deliver as much power.
Gotcha.
Yeah, and but in recent years, the technology has gotten a lot better, so companies are shifting over to LFP. So actually, in the first quarter of 2022, like 50% of Tesla's battery deliveries were LFP. So they've really switched over from their higher performance batteries to this lower performance for their, at least for the lower range vehicles.
Okay. What does LFP stand for?
Oh yeah, sorry. LFP stands for lithium iron phosphate.
Okay. Elements, elements, elements is what I hear.
Yeah.
Sounds good. Who do you know who are the primary producers in the battery market right now? Who's making like the most batteries and what?
Yeah, a lot of companies in China.
Right.
So CATL is the biggest. BYD is another big one. I think LG Energy is the second largest,
Heard of them.
and Panasonic. So a lot of Asian-based battery manufacturers.
LG and Panasonic, they're Japanese, no?
LG is Korean.
LG's Korean. Interesting.
Yeah.
Thanks for the background on the battery stuff. I haven't really done an episode on batteries at all, and I'm excited to talk to you about your business because it's really cool innovating in this space. So why don't you tell me a bit about Rejoule, how it got started, and what impedance
Yes.
impedance is?
Yeah. Yeah, sure. So at Rejoule, we're a startup based in the LA area, and we are developing some advanced battery diagnostics technologies. And so we talked about how there's so many different ways of evaluating a battery. And so our diagnostic tool allows us to quickly understand how well a battery is performing in its lifetime. And then we've designed some technology that it's essentially a device that you would plug into a battery, and it runs a quick measurement. Um, the measurement is called, the technique is called electrochemical impedance spectroscopy, or EIS. So it does this EIS thing, and then it measures a response, and from that we're able to do some um, machine learning to be able to figure out how good is this battery compared to a fresh one, for example.
Gotcha.
Um, and then impedance is, you can think of it as just like a characteristic of, uh, of a battery. And as the battery ages and degrades, its impedance is going to change, and our device is detecting that change and making a prediction on um, how how much energy or how much power that battery is able to deliver.
Cool. And where did this idea come from, and how did you guys develop this like proprietary tech?
Yeah. So EIS is something that's been around, and it's electrochemists all around the world know about it. So we didn't develop that, but our proprietary tech is on how to do that measurement for a higher voltage battery pack. So in battery terms, there's the smallest unit is like a cell, and that's kind of like what you have in your cell phone. You have a single cell, um, and then a vehicle though has hundreds to thousands of cells. Right? So that would be a pack, and then typically that's higher voltage. It's a lot bigger. It's a lot more energy than a just a cell. And then so we've developed a way to do that EIS on not just the cell but the whole pack.
Okay.
Yeah.
And how long does it take like a normal battery testing mechanism or machine previously compared to how long it takes your device to test a battery?
Yeah. So our device is 5 minutes or less. That's the to run the EIS test. The normal way of testing the age of a battery is essentially you're charging and discharging it. So that can take anywhere from 6 to 10 hours.
A long time.
Long time, yeah. And so one of the big things that we're getting at is, well, you're going to have millions of these batteries out there, and if you're
Right.
going to have to test each one, it's going to take 10 hours. You have to use specialized equipment to do it. That's just not really scalable. So we need some faster and more accurate way to be able to diagnose these things.
When are manufacturers testing batteries before they send them to market, or when? How often is this testing going on? Because 6 to 10 hours on an assembly line of a million batteries is a ridiculous amount of time, and then compared to 5 minutes, that's like a game changing opportunity here. So how often are they doing these tests?
Yeah, so a lot of times what manufacturers may be doing is batch testing.
Right.
So if there's thousands of them, then you don't need to test all of, do the 10-hour test on all of them.
Okay.
But for a handful, they do like every test imaginable, even down to cutting the battery open, and they call that destructive testing, just so they can learn everything about those batteries. Um, but typically on a manufacturing line, you may not be testing each of these to that standard or to that type of charge discharge testing. But there are different things that need to be done, and things like formation um, and all this other end of line testing just to check for the quality of those batteries.
Okay. And how long have you all been in business?
We've been in business for almost 5 years, actually. We
Wow.
incorporated our business May 11th, 2017.
Awesome, man. Happy 5 year anniversary. By the time this comes out,
Thank
I think
you.
I think it'll be the next day, if I'm not mistaken. It'll be the 11th. We gotta drop it on the 11th. What is today? Today is the 6th of May.
Yeah,
Yeah. We're gonna drop this on the 11th for your 5 year anniversary. Hell yeah. Um
awesome.
that's so cool. So speaking of 5 years in business, that's, I mean, obviously you're doing something right. Clearly, there's a need for your tech. I'm wondering how the model actually works. Like, who are your customers? What's your revenue model? Are you testing things on site for people? Are you licensing the tech? I'm really curious how you went about doing this.
Yeah. So most of those 5 years, we've been doing essentially research. We've gotten a lot of funding from really amazing groups like the National Science Foundation, the California Energy Commission, um, among others. And so there was a period where we were developing that technology, trying to figure out what to build and who to sell that to. So right now, we are working with customers who they per our value proposition, they have a need for faster testing. They're getting they have batteries that are coming back from their customers, and they need to figure out how good is this battery? Can I send it out for another 3-year lease, or do I really need to do some repairs or just scrap this battery? And so we're selling our product on it's more of a service, actually. We call it grading as a service,
Hmm.
um, and or gas. And so it would be more so on a per month per battery model type of model.
Okay. Is that going to like local businesses then at this point?
At this point, we are working with some smaller manufacturers,
Right.
and we're working with essentially smaller manufacturers and people who are doing a lot of battery testing, particularly with aged batteries.
Right.
We're working on a product right now, which is essentially something you can plug into the vehicle's charging port, and you're able to diagnose the entire, let's say a Tesla Model 3. You plug it into the charging port, we do a test on that battery pack, and then make that prediction. So we're working on that product, and that would be sold to um, either the OEMs, like the car makers, or or to the service garages or dealerships.
Cool. Are there any competitors in the space? Anyone doing something similar? I mean, going from 6 to 10 hours, even if it's a smaller battery, like 3 to 4 to 5 minutes is a total game changer. Did you get,
Oh
I
yeah,
mean, I assume you guys had hella patents. Is there anyone else that's like coming through and doing something similar?
yeah. There's definitely others who see a value in faster testing of these batteries, and I think our technology is the most scalable
Hmm.
in that we can work with the largest range of different battery types and different battery chemistries. Um, but then I do think that some of these other competitors, they have a compelling product as well. And this EV industry and the battery industry is growing so quickly that there's certainly a lot of pie
Yeah.
to be had.
Yeah. It's always a good space to be in, right?
Yeah, yeah.
Totally. Have you put any thought into how battery testing technology can help mitigate like the negative effects of a changing climate?
Yes, definitely. Um, I think one of the biggest things. So there's a McKinsey study that says that in 2030 or by 2030, in just 8 short years, that we could potentially have more used battery capacity um, coming out of electric vehicle batteries or coming out of electric vehicles than the grid demand for energy storage. So
Okay.
that's a lot of batteries that's going to be coming out of electric vehicles, and we can potentially use those for a stationary battery application, like we were saying before. Put it on the grid, charge it with solar, charge it with wind, discharge it during peak hours. Um, so there's an opportunity to do something like that, but the batteries coming out of electric vehicles are not useful unless they are tested. And so we could potentially be sitting on gigawatt hours of not useful batteries that may still have 70, 80, sometimes 90% usable capacity in them. We could just be sitting on those and not being able to use it. Um, Without testing, that can be a very real outcome. And we've actually seen like warehouses where they just have used batteries just lying around. Um, Megawatt hours of batteries just sitting on pallets, and then that's going to accelerate, right? So we definitely need to increase our ability to test and test quickly, so that we could actually know how much longer is this particular battery going to last, and what's a suitable buyer for that battery. Without testing, we don't have that information, and we could just be, you know, wasting all that good battery.
Hmm. I love how everyone's got a piece to play, man. It's really cool to see, especially being here in the states. Well, actually, yeah, I'm interviewing people from around the world, but I'm biased. I love the states. There's always so much innovation and entrepreneurship going on here. So you
Yeah,
back in 2018, you're already thinking about 2030, huh?
yeah, definitely. I
That's
guess that's what entrepreneurs do.
indeed it is, Ben. Yeah, you're a living, breathing example of one. How is it? How has it been over the years, evolving from just an idea to this business? And where's your team at now? How's yeah.
It's been a journey. It's been it's always tough, but it's also really fun. One of the things that I just love is waking up and knowing that I get to do something I enjoy, first of
Huge.
all, and something that I believe can fundamentally um, improve the world in a big way. Um, and so that's always a thing that drives me. And I think the team that we've assembled, and we're still hiring. So for those of you out there who want to do some cool stuff with batteries, go to our website refuelenergy.com/careers. Um, you know, I think the team that we've assembled really jives with that message as well. Um, and so it's just a really exciting time to be in this space. Really exciting time to be a Rajulian, and and we're at about 15 full time right now.
Wow.
Yeah,
Awesome.
yeah. And we're gonna hire some interns over the summer, hire a few more people, and uh, keep growing and keep doing fun battery testing things.
Totally. Yeah. What are your plans for scalability? Where do you see yourselves in 2030 or 2040?
That's a tough question
Yeah.
because as an entrepreneur, you don't really. Um, one of the things that I've realized is every time I really try to plan something, like a week later, it's obsolete. and um, Interestingly, though, our mission that's kind of stayed the same over the past 5 years, but the plans always change. Um, in 2030, I think that we can be the battery repurposing company, um, and we're already expanding into Europe this year, actually, and so we want to be the battery repurposing company globally, working with all kinds of battery manufacturers and automotive manufacturers. Um, and I think by 2030, I don't have the numbers, but I think we have a real shot of being able to repurpose, well over um, gigawatt hours of retired EV batteries per year.
So when you say repurpose, does that mean you guys test it and then you kind of have a network that you forward it to that could be potentially waiting to buy a used battery?
Yeah, yeah, in a way.
Yeah.
Yeah,
Okay.
yeah. We're working with some. We want to be essentially the grading partner, and then
Yeah.
so like you said, we have a network, and they would either be. There's a few companies we're talking to who are building like marketplaces,
Yep.
um, kind of like a storefront where they put up used batteries for sale and connect it to interested buyers, and then we can kind of be a back end, kind of a battery warehouse inventory for those storefronts.
Cool.
Yeah,
Right. Oh. Well, Stephen, thanks for what you're doing. Thanks for your entrepreneurial spirit, getting in there and making use. We need to really use things more efficiently. That's the biggest conclusion I've come to through talking to people about economic-based climate solutions. Is we can fix climate change by improving the economy, and I think something you're
right.
doing is a great example of that. But before we go, I want to give a shout out to the other co-founder of the company and ask your perspective of what it's like. Your sister's name is Zora, right?
Yes.
Yeah. What's it like working with your sister as your business partner?
It's really fun. Just like any business partner, you get into arguments. So there's a good amount of that, but there's also a healthy dose of really lame jokes and inside jokes from like 15, 20 years ago.
Is she older than you?
I don't think I'm allowed to say.
Okay, never mind. You're not allowed to say. She's related to you. That's all that
She's
matters.
related to me, yeah. I've actually answered that before, and people are like, "Oh, that's no, don't do that."
Good job. You're killing it.
I
Yeah.
did better this time.
There you go.
Didn't fall into that trap.
Yeah, I vowed to never work with spouse or family. My parents have run the jewelry store together for 30 years, and just hearing the arguments all day, I'd much rather have like someone when I'm seeing them, like we're not talking about like how to run a business. We're just talking about the
I
trees and the
see.
birds.
Yeah,
But
it's interesting. I think it probably works between Zora and myself because we did see my parents running their business together
oh,
our whole lives. So it was, we talking about business was normal for
mhm.
us. Yeah,
Yeah, I think it's great, man. Just
Uh,
just not for me. But Steven, cool. I appreciate the time, man. A pleasure having you on the show. I'm excited to see where things go. Help us repurpose things. We got to use things more efficiently, man. There's no way around that to get out of the problems that we're facing. Do you have any final pieces of advice for other young folks who are passionate about contributing to a better world?
yes, I'd say just just like those Nike commercials, just do it, um, and learn from move quickly and then really learn from your mistakes quickly, because that's the only way you really move forward. I think way too many times we've overthought something and waited to pull the trigger,
Hmm.
and then it didn't work out, because we waited too long. So try things. Don't be afraid to fail. Just remember that there's always the next day, and you can always improve and keep growing, because that's what we've done.
Spoken like a true entrepreneur. Steven,
Thank
happy 5 year anniversary, man. Here's to 50
you so
more.
much. Thank you
You
so
got
much,
it.
Ethan.
You got it. All right, everybody. We'll see you on the next one next week, whatever. Peace out. So, if you or anyone else you know is looking to buy or sell a home anywhere in the USA and would like to create thousands of dollars in donations without any cost out of pocket, please visit ccrealty.org today.